Hello my friends and welcome to the channel. What we're going to talk about today is Algebra 1. So if you're a parent or you're a student and you're in Algebra 1, say you're in 8th or 9th grade and you're going to go through Algebra and you're stuck, you ought to be able to just follow this course through the lessons here. I'm going to just number these in order, and if you step your way through this, you should be able to make an A in Algebra 1 no problem. So today we're going to start off with just an intro and kind of a review, and then see if we can simplify things, if we can remember how to simplify things that look really complicated. Look at that, it's just overwhelming, isn't it? We can't do it. Yes, we can, it's not that difficult. And I'm going to show you how, okay? So what we're going to do today is combining like terms. Okay, now what is a like term? That would be like, you know, if you had a fruit stand and you had a whole bunch of fruit and it was all mixed up, and you wanted to see how many apples you have. Well, I can only add apples to see how many apples I have. Then I can see how many oranges I have and how many bananas I have. And it's the same way with like terms. So if you think about as C maybe is an apple and D is a banana. Well, I'm going to see how many apples I have. So I'm going to add the things up that are apples to each other, and I'm going to add all the little oranges together or whatever. And then I'm going to see how many like terms I can gather up, and all we're doing, we're not changing this, we're just reducing or simplifying it to something that's easy to work with, okay? So we could say that this reduces to, okay? So let's see what it reduces to. Now I'm going to use colored markers here to help you kind of see those like terms, okay? So we have two in this particular example. We have two things. We have C's and we have D's. Okay, so I'm going to put a little red line under all the C's. One there, one there, one there, one there, and one there, right? So the little red guys, you'll put a little box around them so they really stand out. Okay, we have to add all those up, okay? So that's all the apples. I'm going to add those up and see how many apples I have, okay? Now, here's the thing. Notice this has a coefficient in front of it. The coefficient is this solid number, or that number there, the integer. This means 4 apples. This means 1 apple. Well, what does this mean? Well, that's 1 apple also, isn't it? This and that are the same. Because if I multiply 1 by something, what do I get? Just the something, right? So this and this are the same things. They both are the same thing. So we could treat this, there's like an invisible 1 in front of that, okay? So all we have to do is add these terms together and we'll get the C term. So let's do that. Let's go. Here we got 1 plus 3 more, that's 4. Minus 1, that puts us back to 3. Minus another one, that puts us at 2. And then plus 4 more, that makes us 6 of those guys, doesn't it? So 6 C's, or 6 apples. Okay, let's see how many oranges we got. Here, look, I've got an orange pin for the oranges. Okay. So here's the oranges. There's one there, and one there, and one there, and one there, right? And this, if you've got little colored pens, get them out and use them. That'll really help you kind of simplify that. Another thing you can do instead of using colors, if you don't have a colored pen, is draw shapes. Maybe draw a square around the C's and draw a triangle around the D's so that I can see them real visually and group them together real quickly. So let's add up our oranges and see what we have. There's 1. Plus 3 more, that's 4, plus another one, that's 5, plus 3 more, I'm going to carry that, that's 8. Okay, so plus 8D, right? So what have we done? We said that this here, if we add all that together, it simplifies to just this. So it's much easier to write that than it is to write that big mess over there, right? So all we're doing is combining the like terms. And we're going to do that on all these. And so it may look daunting, but it really won't take us very long because we're going to start to get the hang of it real fast, right? Okay, let's do the next one. We're doing it in green. Okay, here we go. Ready? What 2 colors we're going to use this time? We're going to use, I don't even know what color this is. I can't use blue, Hardy. Okay, what color is that? Salmon. It's really ugly. Okay, so what do we have here? Now wait a minute, I've got a C here, and a C there, and a C there. Are those the same C's? Well, the answer is no, okay? If it has an exponent, it's a different C. It's like That's an orange, but that's a navel orange, right? It's a special kind of orange. This one is different than that one. It looks like it, but it's not the same. That's square. So I can only lump terms together that are like. This guy doesn't have a square, so he's not like that guy, okay? So let's see. I'm going to do the c squares. There's a c squared. There's a c squared. You see any more? I don't see any more, okay? So let's do the c squares. What do we have? Okay? We have 8 c squares minus 3 c squares. That leaves us with 5 c squares. Okay? And let's see, what else do we have? Now we have the d's. Here's a d to the 5th. Do you see any other d to the 5ths there? Uh-oh, I don't see any more. So I've just got 1 there. So plus 4 d to the 5th. That's the only one there is. Let's see. Here comes a d to the 4th. Right? Oh, that's the only one of those guys too, isn't it? So that guy's not going to change. 5 d to the 4th. Okay? And then what? I've got the 2c, he's by himself, and the 5 is by himself. Okay, so we're going to just do minus 2c minus 5. Now let's talk about one more thing, and that is kind of a numbering convention, or the way you write these down, a convention. Now, it doesn't make it wrong, but typically what we'll do is put the letters in alphabetical order. So we'll do A, B, C. In this case, we'll do C and then D. Okay, so we'll put those in order. And then we'll also put these in order of the exponent. So the biggest exponent will go first, and then we'll go down to smaller exponent with the constants being at the very tail end. So let's just shuffle this around and rewrite that. Now this one's already in the right order, right? Because if you do alphabetical order, C comes before D, so that one's good, right? So let's do this one here. So we're going to start off with C first. So we're going to do 5c squared, and then we'll move the other c over there, minus 2c. Now our c's are in alphabetical order. And then we'll do what else? The d's, right? Plus 4d to the 5th plus 5d to the 4th. We're descending here. And then the minus 5 on the end. Okay? And that's how we would typically write that. So alphabetical order first, and then your exponent second. Okay? Easy. Okay, so these are going to be the same thing, just more of them. So if you're doing this along with me, why don't you just push pause, see if you can get it, then push play, see if you get the same answer I do, then push pause, right, so on and so forth, and work along with me here, and we'll solve these, okay? So I'm going to solve this first one here, okay? You push pause, see if you can get it. Ready, go. Okay, here we go. These are already like, aren't they? The A and the A is like, so this is as simple as just adding these two together. This is simply 7A, okay? Easy. All right, next one, what does this guy reduce to? Push pause. Okay, what do we have? This is all B's, right? This ought to be easy. So I've got negative 12 of them, and then if I add 6 more to that, I've got negative 6 of them, and I add negative 4 more. Remember, negative and a negative, that just makes the negative bigger, right? So I was at negative 6, and then 4 more makes that negative 10B, okay? So that's what that reduces to. Okay, number 3. All right, push pause and work it out. Okay, here we go. Let's combine the terms here. Let's see, I've got some a squares. There's an a square. There's an a squared. That's all of them. So 5 plus 7 is 12. Okay. Then I'm going to do my a's, right? Here comes my a's. I'll do them in orange. I've got an a there, and an a there, right? And so that's going to be what? Minus 6 plus 3 gives me minus 3, and minus 3 plus 8 is going to be 5. So plus 5a. And then what's left? The only thing we haven't added up are the constants, so they just go together, and 7 minus 2 is 5. So plus 5. And we have these in order of the exponent, right? The biggest exponent, and then this is a little understood 1 exponent. And there you go. Okay? Number 4. Okay? Let's see if you can reduce number 4. Hit pause. Okay, here we go. Let's see, what do we got first? Let's do the cubes first. Let's just always do the biggest exponent first, and we'll just work down from there, okay? So let's see. See how you know they made a brown pen? That was not very attractive. Here we go. The x cube, I got 1 there. I got an x cube there. That's it. So 9 plus 4, well, that's 13. Okay? And what do I have next? Let's do the x squareds. Okay, there's 1 there, and there's 1 there, right? So the orange ones I'm adding up. I've got a -7 there, and -3 there. That's a -10. Okay, and then what's left? That's all that's left, minus x. Right, and those don't go together. And look there, descending exponents, knocked it out. Okay, next one, number 4. Okay, hit pause. Okay, here we go. Let's see. We got, we'll do the h squareds first. Okay, so I got an h squared there, an h squared there, no more. Okay, so 2 plus 2, that's hard, 4h squared, all right? Now do the h's, we'll do them in red. So I've got an h, let's see, I got an h there, an h there, an h there. Oh, there's another one over there. There's a lot of them, aren't there? So here we go, let's add up the red ones. -7 minus 1 is -8, plus 4 is -4, and then -9 is -13, isn't it? Let's see, that's not an h squared, that's just a plain old h, isn't it? Okay, what's left? Let's see, what's left is, oh, that's the only guy left right there, right? So just plus 6. Done. Okay, are you getting these right? We should be doing good, right? All right, here we go. Number 6. Oh, this is gonna be weird. Look what we have here. We got all kinds of weird stuff going on. The exponents, we got stuff multiplied together. Don't be confused by this, okay? An AB is just a different kind of fruit, right? That's a mango. I don't know, right? So I'm still going to group these together, okay? So I'm going to group. Let's say I group we'll do the big exponents first, okay? So we'll do this guy first, okay? Now that guy's an a squared b. What about that guy? That guy's an ab squared. It's not the same as that. The b term is squared there and the a term is squared there. It has to be like terms. They have to be exactly alike, okay? So that's an a squared b, but here's another a squared b over there, okay? So what, 3 plus 5, that's around 8. 8a squared b, okay? Now, following our exponent rule here, let's go ahead and do, oh no. Let's go ahead and do this ab squared next, okay? Now he's the only one of those, right? So plus 4ab squared, okay? And then what's left? These two guys here, and they're the same, aren't they? Both of these guys are ABs. That's an AB, that's an AB. So that's an apple and an apple, isn't it? And 4 minus 6 is minus 2. Okay? That's not so bad, right? Just because it has 2 variables in it, don't be scared by those. Treat it just the same, okay? Number 7. Number 7. Ooh. Now this one's going to be hard. Let's see if you can do it on your own. All right, push pause. Okay, gang, here we're going to start off again with the biggest exponent. Let's see if we can do this, okay? Oh my goodness. Let's start off with the, I think the x squared y squared is the biggest, right? X squared y squared, x squared y squared. Ooh, I have a question for you. If I change this around over here, let's just change this. What if I made it like this? What if I made it y squared x squared? Oh, is that going to mess you up if that's x squared y squared and that's y squared x squared? No, those two are exactly the same still, because the x is squared, the x is squared, the y is squared, the y is squared, right? They're the same thing, even though they're written in backwards order. So don't let, that might be a trick they put on the test to try and catch you. But they're not going to catch us, are they? Because that guy is the same, okay? So what do we have here? We got minus 4 plus 3. That leaves us with 1. No, minus 1, right? And then minus 1 minus 7 more. That's minus 8, isn't it? So minus 8 x squared y squared, okay? Next, here we go. What do we got next? We did the x squared y squared. What about that guy? What about that guy, the orange one? Xy squared. That's not, that's the only one of those, isn't it? So he's just going to be straight on there. So plus 2xy squared. He's all by himself, isn't he? Okay, and then finally, what do I have left? I have, there's an xy, there's an xy, right? So I got to add the green ones together, all right? And the green ones are what? 7 plus 6. Well, that's 13, isn't it? Plus 13xy. And that should be it. And again, they're in order of the biggest exponents going to the smallest, okay? Are you doing good? We only have 2 more to go. Okay, how about number 8? Look at this guy. It's got all kinds of stuff in it. 4s and 3s and 4. Don't be intimidated. Same way as we did the last one. Okay, push pause, see if you can do it. Okay, gang, here we go. We got this, okay? Here we go. We're going to start off with the biggest exponent, which I think is the 4s, right? So there's one right there. May the 4s be with you. Okay, sorry. And there's another one over here. Okay, so let's see if we can add up the fourths here. So 4, h to the 4th j, that's an h to the 4th j, that's an h to the 4th j. So 4 plus 13, 17, ooh, minus 17, that's 0, isn't it? Okay, so the green ones are just going to go away. I'm not going to write anything over there because it's 0, right? So let's go to the next one, which is the cubes, right? And here's a cube here. Now this is h cubed j. I got to make sure these are the same. This is a h cubed j squared. Sorry, that's h cubed j squared. So those two are the same. Okay. So what is that? 15 minus 14 is 1. And remember that 1 is kind of understood. It doesn't have to be there. So we could just put h cubed j squared. That's all we'd have to put there, right? And then there's nothing else left. So that whole business simplified to that. All right, did you get it? All right. Last one, and you're going to be the champ of combining like terms, right? Here we go, last one. Okay, what is this big mess here? Oh, this is a hard one. Look how long it is. It goes all the way over there. Okay, push pause, see if you can do it. Okay, are you back? Here we go. We're looking for the biggest exponent. What's the biggest? Just see. I see a cube and I see a cube. So let's do those first. Okay, so we got what? X cubed y squared. Oh, that's what that guy is too. Okay, so those two are going to go together. That's all I see. So 8 minus 6 is 2. X cubed y squared. Okay, so that's that one. Next. Okay, no more brown. How about orange? So the next one is the squared terms. So I've got a x squared y. I've got an x squared y. I've got an x squared y. That's it, right? So minus 7, minus 6 more, that's minus 13, isn't it? Plus 2, that's minus 11. Plus 4 more, that's minus 7, isn't it? So minus 7x squared y. And what's left? How about just the plain old x's? We'll do those in red. Okay, there's an x right there. There's 1 over there. Is that it? That's it. So 8 minus 3 is 5. Okay? And then the last thing is all we have left are constants, right? So we just add up our constants. So we got 4 there and we got 5 there. So 4 plus 5, 9. And our equation is written in the correct form too, right? So there you go. How hard is combining like terms? Not too bad, right? That's step 1 for doing the algebra problem, is to get everything in simple. Because if they give me a big equation, I want it simple. Then I can solve for what is C, what is D, okay? And that's what we're working towards, okay? So if you keep following along with these lessons, A+ for you. See you next time.